Hi everyone, once again welcome back to our class. Now we are going to discuss about the numerical problems based on the kinematic equations of motions, some concepts and some problems. Now this is a topic here, motion in a straight line. A given problem right there, here see here, listen carefully. ఈ చెప్పే క్వశ్చన్స్ చాలా ఇంపార్టెంట్, కాన్సెప్ట్ ఓరియంటెడ్. తర్వాత వీటిపైన మనకి ప్రాబ్లం చెప్తా ఉంటా. చూడండి, మీ ఫ్రెండ్స్కి షేర్ చేయండి. ఓకే, నౌ యర్ ప్రాబ్లమ్ ఈజ్ దేర్, వెరీ సింపుల్ ప్రాబ్లమ్ అండ్ ఇంట్రెస్టింగ్ ప్రాబ్లమ్. నౌ యర్ క్వశ్చన్, దిస్ ఈజ్ అ క్వశ్చన్ ఈజ్ క్వశ్చన్ నెంబర్ 1. The two ends of a train moving with uniform acceleration, here A, for example, pass a certain point with velocity here u and v. Find the velocity with which the midpoint of the train. Find the velocity with which the midpoint of the train passes the same point. So find out the velocity at the midpoint of the train. So the train moving along the straight line or moving with uniform acceleration here. The velocities, its ends of the velocities of the train here u and v. Find out the velocity at midpoint of the train here. Question here, this is one here. For example, this is a train. Okay, AB is a, for example, train. AB is a train. These AB ends of the train. So the distance of the length of this train here, for example, yes. Length of the train yokka podavu mottam, for example, yes. Okay, yes. Now the midpoint of the train, for example, here this is a midpoint of the C is a midpoint of the train. Here C is a midpoint of the train. Now AC and CB, this is a equal distances, so equal length of the train. This is a BC, that means here AC is equal to CB, that is equal to here S by 2, this is a S by 2. Okay, ikkada AC is equal to BC, this is a C is a midpoint of the train. Now find out the velocity of the train at midpoint. So here velocity of the train at midpoint, for example, v prime, for example, v prime. So initial one end of the velocity here u, another end of the velocity, for example, v. Now find out the velocity at midpoint. So question mark here is there, v prime is equal to question mark. Ikkada C means midpoint of the train, v means velocity of the train at midpoint. So find out this question mark. Now the train moving along the uniform acceleration, this is moving along the uniform acceleration. First of all, the velocity of the train at midpoint. Now first of all, the third equation of motion, the third kinematic equation of motion ante మూడవ చల సమీకరణం. సి హియర్ v square minus u square is equal to 2as formula. This formula using, now this is a formula using, in between here AC, between first one here between AC is here AC, displacement of in this one s by 2, this is a midpoint, so s by 2, acceleration here a, here also acceleration a. So between AC, this formula using, final velocity here v prime, initial velocity here u. So v prime square minus u square is equal to 2a. Here s is equal to s by 2, here s is equal to half of the length of the train. Now that means here s by 2. Next, between here point C and B, so here between CB, so CB for this equation 1, CB means here this is a v square minus u square. Here initial velocity in this case here v prime, here final velocity v. Now final velocity minus initial velocity, here v square minus v prime square is equal to 2a uniform acceleration. S is equal to half of the length of the train, so that is equal to here s by 2. This equation 2. Okay, now 2a s by 2, 2a s by 2, so these are here same. Equation 1 is equal to equation 2. Equation 1 is equal to here equation 2. Now from equations here, from equations 1 and 2, 1 and 2, so equation 1 is equal to here equation 2. Equation 1 is equal to here equation 2. Equation 1, this one v prime square minus u square, v prime square minus u square is equal to equation 2 here v square minus v prime square, v square minus here v prime square. So simplifies here, this is taken left side, this one here v prime square taken as here left side, and initial velocity one end of the train here taken as right side. So simplifies here v prime square plus v prime square is equal to v square plus here u square, v square plus here u square, that is equal to v1 square v1 square. So 2v prime square is equal to v square plus u square. Simplifies here v prime square is equal to v square plus u square by 2. So finally the velocity of the midpoint of the velocity of midpoint of the train v prime is equal to under root of here v square plus u square by 2. This is a velocity of midpoint of the train, So this is equal to formula here, the velocity of midpoint of the train is equal to v square plus u square by 2 under root. This is a equation, this is a question to answer. Very important, very concept oriented problem. Now next, for example, here one example problem, the velocity of the ends here, for example u is equal to, for example here very simple, u is equal to 75, u is equal to u is equal, for example 100, and v is equal, for example here 300 meter per second. Okay, now find out the velocity of the midpoint of the train. So here v prime values, so question mark. So this values here substituting this simply, ante ee values ni akkada substitution ante ikkada end దగ్గర ఎంత 100 meter per second, here end 300, for example, just example, concept oriented. So this values here in this formula v prime is equal to under root of v square plus here u square by 2. V square nothing but here 300, 3 3 999 plus u here 100, so 10,000 by 2 under root. So 10,000 plus 90,000, that is equal to here how much here 5 zeros. Okay, 5 zeros by 2 under root. Simplies 2 1 ja 2 5 ja, remaining 5 zeros, that is equal to here v prime is equal to simply here 5 into 10 power of 4, that is equal to here simply 100 square. So this is a square, this same in how much here, this is a 100 under root 5 meter per second. This is the answer. This values here 100 into root 5 meter per second at the midpoint of the train. For example problem ante ikkada manaki just example. Next question, know this one first of all. See here, next problem, this is the concept for oriented equation. Now here, if a particle start from rest u is equal to 0 and moves with uniform acceleration a such that it travels distance sm and sn in the mth and nth seconds, then here a is equal to sm minus sn by m minus n. How to this formula we will get? Now once again question here. If a particle starts from rest and moves with uniform acceleration a such that it moves distances here sm and sn in the mth and nth seconds, then a is equal to here acceleration, uniform acceleration a is equal to sm minus sn by m minus n. Now how to solve this type of problem? Now here first of all sn formulas here. Sn is equal to u plus a into 2n minus 1. This is a sn to distance. Now first of all the particle moving along the straight line in m seconds is sm seconds. That means here this is a formula. First equation here, sm is equal to u plus a by 2m minus 1. So according to your initial velocity u is equal to 0. So now sm is equal to 0 plus 1 by 2m minus 1. This is equation 1. Next one, sn times the displacement of the particle in sn seconds, nth seconds and nth seconds. This is a mth seconds here, this one here nth seconds. Now is equal to here u plus 1 by 2n minus 1. So here u is equal to 0, sn is equal to 0 plus a by 2n minus 1. Now finally sn is equal to a by 2 into 2n minus 1. This is equation 2. This is equation 1 to this equation here. Mth displacement here nth seconds here mth seconds. Now displacement here sm is equal to simply a by 2 into 2m minus 1. This is equation 1. So this is equation 1. Now we find the uniform acceleration of the particle. Now here a is equal to sm minus sn by s. So in this case here equation 1 by 2 or 2 by 2, or here equation 2 minus equation sm minus sn. Okay, here from equations now here equation 1 minus equation 2. Equation 1 formula is this one here, sm minus equation 1, this equation 2, this one here sn is equal to equation 1, that nothing but 1 by 2 a by 2 into 2m minus 1 here minus to equation 2. So a by 2 into 2n minus 1. Now a by 2n minus 1. Here a by 2 is a common term. A by 2 is a common. So simplifies here a by 2 common terms. So 2m minus 1. Here this is a minus. Here now minus. So minus into plus minus. So 2n minus into minus plus 1. Minus into minus 1 plus 1. So any terms get cancel terms in this equation. Now negative minus here positive minus, negative 1 and positive 1. So remaining simplifies here mn minus sm minus sn is equal to remaining terms here a by 2 into 2m minus 2n. So 2m minus 2n. Now this is okay, here simplifies sm minus sn is equal to 2 is a common terms here 2a by 2 into here m minus n. So here 2 get cancelled, 2 get cancelled. Simply finally here sm minus sn is equal to remaining here a into m minus n. So therefore uniform acceleration of the particle a is equal to finally here m minus Sn by m minus n. This is the answer. This one here answer. Okay, this is the final answer. This one. Okay, once again in this, for example, first of all formula here s is equal to u plus 2n minus 1. Okay, this is a Sn formula. Sn to second displacement of the particle. Now ఇక్కడ నుండి తీసుకుంటున్నాం Sm is equal to this one. So Sm is equal to finally a by 2m minus 1 and nth seconds displacement here Sn is equal to u plus of a into 2n minus 1. Here u is equal to 0. Finally here Sn is equal to formula how much here a by 2n minus 1. So equation 1 minus 2. So from equations 1 minus equation 1 minus equation 2, this is a equations. Now here this term equation 1 terms, this term here equation 2 terms, this one here equation 1 term. This is a equation 1, this is equation 2. So this is 1 minus 2 simplify. Finally uniform acceleration of the particle a is equal to Sm minus Sn by m minus n. Now this is a question. Now after some problems explained in this formula, next question, note this one first of all. See here, next one, concept oriented equation for formula. Now a particle start from rest. A particle start from rest. That means here u is equal to here 0 and moves along a straight line. Moves along a straight line with uniform acceleration. Uniform acceleration. So a uniform acceleration, a is a uniform acceleration or constant acceleration. Now if s is here, if s is the distance traveled in n seconds, traveled in n seconds, that means here t is equal to n seconds, t is equal to here n seconds, and Sn is the distance traveled in nth seconds. Here t is equal to here, t is equal to here nth seconds. Okay, seconds. Then Sn by s is equal to 2n minus 1 by n square. So solve this problem, solve this equation. Now once again here a particle start from rest and moves along a straight line with uniform acceleration a. If s is the distance traveled in n seconds and Sn is the distance traveled in nth seconds, then Sn by s is equal to 2n minus 1 by n square. So how to solve, how to we will get this formula, how to we will get this formula. Now first of all here second equation s is equal to ut plus of at square. This is a formula, general formula. Here s is equal to ut plus of at square. Now first of all the particle moving along the straight line in n seconds. Here first condition, this is a s displacement. Here t is equal to here n seconds, t is equal to here n seconds. So this is a displacement, first condition. So here s is equal to un square plus here 1 by 2 an square. So n seconds the particle moving along the straight line, n seconds the displacement of the particle. Yes, next condition here, next one here, if next one n seconds, Sn is the distance traveled in the nth seconds. Here nth seconds, Sn means n seconds. Here t is equal to here nth seconds, t is equal to n seconds, that is equal to here Sn is equal to u plus a into a by 2 into n minus 1. Here Sn is equal to u plus a by 2 into 2n minus 1. This is the nth seconds, this one just to n seconds. Okay, now equation first of all, the particle travel in n seconds, the distance traveled in n. Answer, the distance traveled in n seconds, n seconds. Here n seconds s is equal to un square plus n square by 2. Okay, this equation 1, this equation 1. Next one, the distance traveled here in nth seconds. Here nth seconds, here Sn is equal to u plus u plus here a by 2 into 2n minus 1. This is the equation 2. This is a Sn seconds. This one is only for here s seconds. Now we will get formula Sn by s. That means here equation 2 by equation 1 from equations here, from equations, okay, equation 2 by here equation 1, equation 2 by equation. So here equation 2, this one here in this formula s is now, okay, Sn by s, equation 2 by equation. So here Sn formula u plus a by 2 2n minus 1 by here is formula u n square plus a n square by 2. Now according to given problem here, given matter, the particle starting from rest, that means here initial velocity u is equal to 0. Initial velocity here u is equal to 0. This u values here substituting in this one, here u is equal to 0, so this is equal to 0. Now note this one, first of all this one, okay, this one. Now here simplies remaining here Sn by s is equal to u is equal to 0 plus here a by 2 into 2n minus 1 by here a is equal to 0, sorry, u is equal to 0 nothing but something values multiplication is 0, so u 0 into n, so 0 plus remaining here a n square by 2, simplies here Sn by s is equal to remaining terms here a by 2 into 2n minus 1 by a n square by 2, so this is a denominator, this also here denominator, so here one step Sn by s is equal to this denominator reverse, so a into 2n minus 1 by 2 into here 2 by a n square, so here a get cancelled, and 2 get cancelled, so remaining terms here Sn by s is equal to 2n minus 1 by n square, this is the answer, this one here answer, okay, final answer here, this is the answer. Sn by s is equal to 2n minus 1 by n square. This is a given problem. Multiple choice lo ichche avakasham untundi, okay. Note this one first of all. Next problem, see here next one, concept oriented, fourth one, this one here fourth one. Interesting problem, interesting question here. See here, the velocity of a body becomes 1 by nth of its initial velocity, initial velocity, for example u, okay, after a displacement to x, here x, then it will come to rest, after a further displacement of x by n square minus 1, further displacement of particle here x by n square minus 1. So how to this type of problem solved, how to we will get that formula, that equation. So after displacement of the particle come to rest here, for example y is equal to x by n square minus 1. So here very simple question, once again listen, the velocity of a body becomes 1 by nth of its initial velocity after a displacement of x, then it will be come to rest after further displacement of x by n square minus 1. Here first of all, see here first of all 2 points here, these are a and b, 2 points, the total distance of the particle traveling in between a to b, అంటే ఆ పార్టికల్ అని ఏ బీల మధ్యలో మొత్తం ట్రావెల్ చేసిన దూరం, ఓకే. First, initial velocity, for example, here u. Initial velocity, starting velocity of the particle here u. Next, come to 1 by nth of the displacement n. A2 displacement here x. Initial velocity here x. Initial velocity, sorry, initial displacement, for example, initial displacement, this is a, it's come to b comes 1 by nth of its initial velocity. Initial velocity after a displacement of x, ante x tarvata then displacement x after x displacement here, this is a c point. So the velocity of the particle here, initial velocity 1 by n, that 1 by nth of its initial velocity. That means here the velocity, final velocity here, final velocity nothing but here, this is a u by n, okay, a point to raise the point c. Final velocity v, that is your final velocity v, then nothing but 1 by nth of the its initial velocity. That means u by n. Okay, at point c, the velocity of the particle here u by n. Now after the body come to rest at point b, this body come to rest at point b, so remaining displacement of the particle, for example y, remaining displacement of the particle here, for example, so this y is equal to x by n square minus 1, x by n square by x by n square minus 1. Now ఇక్కడ చూడండి, here final come to rest, here finally the body come to rest, okay, come to rest. That means here final velocity is equal to here 0. Final velocity is equal to 0. Now according to third kinematic equation of the motion, so v square minus u square is equal to s. ఇక్కడ once again AB is a AC is a initial displacement of the particle. This displacement the initial velocity u, here final velocity of the body at c point here v nothing but here 1 by nth of the initial velocity. Next, the body come to c to b, so finally come to rest. Final velocity here v is equal to 0. Initial velocity in this case here v is equal to u by n. Now here condition from equation from v square minus u square is equal to 2as formula, from here v square minus u square is equal to 2as formula. So first got in between AC, in between here between AC, okay, here AC, here u is equal to u, v is equal to u by n, and here displacement s is equal to x, the particle moving along the uniform acceleration, so a is a constant, here a is a constant both, okay, so a to c, c to b. Now here a is equal to just a. First condition, in between AC, so in between AC, this formula, this values here substituting, v means here this values here, okay, u by n whole square minus initial velocity here u is equal to just to u square is equal to a, yes, s is equal to displacement of the particle to reach the point c, so just x, here x. Now in this one, this is case 1, this is a case 1. Next, the between here c and b, so c and b in this case here initial velocity u is equal to this is one initial velocity u by n, and your final velocity v is equal to 0, final velocity u is equal to 0, your displacement s is equal to here, in this case is just here y, we find out the displacement of the y, so here s is equal to y, here a is equal to a is a uniform, Now this values here in this case, in this formula. Now here this one u means v means here 0 scale, okay, 0, and formula, okay, v square minus u square is equal to 2as, v square is equal to v is equal to 0 minus u is equal to here u by n square is equal to here a 2a, here s is equal to y, displacement of the particle to reach the point b, okay, here y. Now simplifies here minus u square by n square is equal to 2ay 2ay. Now this one equation here, this is the equation 1, this equation 2, equation 2. Now equation 1 is equal to equation 2. For example, equation 1 is equal to equation 2, or here in this case here, in this case equation in this case here 2a is equal to u by n square minus u square by x. Okay, in this case here ua is equal to minus u square by n square by y. ఇక్కడ చూడండి, ఫ్రమ్ ఈక్వేషన్ 1 here, from equation 1 2a is equal to u by n square minus u square by x. Okay, u square by, from equation 2 here, from equation 2 here, from equation 2 nothing but here 2a is equal to here minus u square by u by n square by y. Okay, this equation 2. So here 2a is equal to from equation 2a is equal to u by n square minus u square by x. 2a is equal to minus u by n square by y by. So equation, now we want here displacement of the particle to reach the point b, అంటే b will point in చేరినప్పుడు దాని యొక్క స్థానభ్రంశం from the c to b displacement of the particle. So y is equal to, now equation 1/2, note this one first of all. Okay, note this one, very simple explanation. So we want y is equal to, here y is equal to, from equation 1 is equal to here, this is a okay, this equation 1, for example this one, okay, equation 1 is equal to here, equation 1 is equal to equation 2. Equation 1 nothing but here u by n square minus u square is equal to by x. Okay, by x is equal to, remaining here u by n square by y. Now this is a simplifying after, you will LCM, this is u square is a common terms, simplifies here u square common terms. So 1 minus here n square, 1 minus here n square, this one negative values by here n square x is equal to this terms here u square by minus u square by n square y, n square y, just n square y. Okay, now any terms get cancel terms here, this one here, this one cancel, u square is a get cancel, remaining simplifies here, remaining 1 minus u square by here n square x is equal to remaining okay, here terms n square get cancel, n square get cancel is equal to minus 1 by y. So simplifies here, we want y values, the displacement of the particle to reach the point b from to point c. Okay, y is equal to cross multiplication just here minus x by 1 minus x square minus x by 1 minus n square. So now simplifies here y is equal to x by n square minus 1. This is our answer, this one here answer. Okay, note this one first of all, here the displacement of the particle to reach the point b or come to rest after displacement to x, y is equal to here, y is equal to x by n square minus 1. Okay, these are problems. Now next class some numerical problems based on these equations. Okay, thank you, all the best.